We want to find out what values are assigned to B as a result of this set of MATLAB commands. First, we're given a matrix A. It's a two-dimensional matrix that has both rows and columns. I'm going to write that in two-dimensional form. So A is equal to, the first row is 0 and 3. The second row is -2 and 1. The third row is 6 and -4. Now we have a set of nested for loops. The inner for loop goes from here to here. The outer for loop goes from here to here. And inside the inner for loop, there's a decision being made. So we're going to have to keep track of what I is and what j is. We'll also have to keep track of a of I comma j, and we'll set that as b of j comma I. Now between a of I comma j and b of j comma I, the only thing that will change based on this decision here is the sign on what goes into b of j comma I. So these are the four things that we've decided we need to keep track of. The outer loop sets up a vector I, which starts at 1, increments by 1s, and goes to 3. So I is an array containing 1, 2, 3. J is also an array that starts at 1, counts by 1, but only goes to 2. So the first time through this outer loop, I is equal to 1. With I equal to 1, we go do this entire inner for loop. We have to finish everything inside a loop before we can increment I to its next value. So the first time through the inner for loop, j is equal to 1. So if I is greater than j, which is not true, so we don't do that, we do this. So b of j comma I is equal to negative a of I comma j. So with I and j both being 1, a of I comma j is 0. Changing the sign on that, b of j comma I is 0. Now we have to go to j equals 2. When we hit this in statement, we go back to the for statement, pick up the next element in the array. So the second time through the loop, we haven't finished the outer loop first, so I is still 1. J is 2. A of I comma j, first row, second column, is 3. Now in this case, I is less than j, so this is not true, and we change the sign on b of j comma I. That becomes -3. That finishes our decision, so we go to this in statement, which brings us back to this for statement. We finished all of the elements of j this time through, so we've done everything inside the outer for loop, which takes us down to this in statement, and we move to the next value of I, which is 2. We move into the inner for loop. We start counting over again with j equals 1. It goes back to its first element, so 2 comma 1. A of I comma j is -2. Now we check to see whether I is greater than j. In this case it is greater than j, so this is true. We do that. B of j comma I is the same of a I comma j, so this becomes -2. Now we finish the decision. We go to the next element of j. We haven't finished the inner loop yet, so I stays at 2. J updates to 2, its next value. A of 2 comma 2 is 1. In this particular case, I and j are the same, so I is not greater than j, and we change the sign on a of I comma j to make it -1. Finishes this decision. Our inner for loop is also finished. We've done both j equals 1 and 2. So we're done with this for loop. We go to this in statement, and we pick up the next value of I, which is 3. The inner for loop starts over again, so j starts counting at 1 again. We check to see if I is greater than j. It is. So b of j comma I is the same as a of I comma j. If I is 3 and j is 1, a of I comma j is 6. We don't change the sign, so this becomes 6. Now we go to the next value of j. So j is equal to 2, but I remains 3. 3 comma 2, a is -4. We check to see if I is greater than j. 3 is greater than 2, so we do this. We don't change the sign. That becomes -4. Now, these are the elements in B, except that j now counts the rows of B, and I counts the columns. So B is going to be here. First row and first column is going to be 0. Second row, first column is going to be -3. First row, second column is going to be -2. Second row, second column is -1. Down here, the first row, third column is 6. And the second row, third column is -4. So this is our matrix B.